While it's great that there are sentiment lexicons available, for lots of other purposes, we'd like to build our own sentiment lexicon. And the way we do this is often by semi-supervised learning. And the idea of semi-supervised learning is we have some small amount of information. Maybe we have a few labeled examples, or maybe we have a few hand-built patterns. And from that set of data, we'd like to bootstrap a complete lexicon. And we might want to do learning of lexicons instead of taking an online lexicon if we're looking at a particular domain that maybe doesn't match the domain of the lexicon that was built, or we're trying to do a particular task, or maybe we just think that our online lexicons might not have enough words that are relevant to the topic we're looking at. One of the earliest ways of inducing this kind of sentiment lexicon was proposed in 1997 by Hatzivatsaloglu and McEwen, and I'm going to show you this because although the paper is old, this intuition is included in almost all modern ways of doing this semi-supervised learning of getting a lexicon. And their intuition, very simple, is that two adjectives, if they're conjoined by the word and, they probably have the same polarity, and if they're conjoined by the word but, they don't. So if you see on a very high frequency of fair and legitimate or corrupt and brutal, probably fair and legitimate are both on the same polarity. And so we might suspect that fair and brutal are just less likely to occur on the web or in some corpus. And so if we see a lot of something occurring with and, maybe the two are likely to have the same sentiment. But if we see two words linked by but, they probably have different sentiments. So fair but brutal more likely to occur than fair and brutal. And here's how they use this intuition. They first labeled by hand a seed set of 1,300 adjectives. And so they had about a similar number of positive and negative adjectives, so central or clever or famous or thriving, and negative adjectives like ignorant or listless or unresolved. And now from the seed set, they expand that to any adjective that's conjoined with a word in their seed set. So for example, we can go to Google and we can type in was nice and look at what words occur next. And what do we see after was nice and? Well, we see was nice and helpful. So that tells us that nice and helpful are likely to have the same sentiment. And here we see nice and classy. So that tells us that nice and classy might have the same sentiment. And we can do that for all sorts of words that occur conjoined with our seed set. And we take any word that occurs frequently enough in the right conjunction with our seed set words. And now we can build from that a classifier, and the job of the classifier is just to assign for each pair of words how similar the two words are. And so we can give the classifier the count of the two words occurring with an and in between them, and a count of the two words occurring with a but in between them. And the classifier can learn that nice and helpful are somewhat similar, nice and fair are very similar, fair and corrupt are very dissimilar. I've marked them in red with a dotted line because maybe but occurs much more often between these two and occurs more often between these two, and so on. So we can get between any pair of words a number that indicates its similarity. And now we can just cluster the graph and use any kind of clustering algorithm. And we get for the words that tend to be linked together, helpful and nice and fair and classy, we'll get that these are linked together, and brutal and corrupt and irrational are linked together, and we can get our output polarity lexicon. And here I've shown you an output polarity lexicon, and of course it'll have some mistakes in it. So see if you can find the mistakes in this lexicon. Here are some of the mistakes. So we have disturbing as a positive word, or strange as a positive word, or pleasant as a negative word. So of course there's going to be errors in any of these kind of automatic semi-supervised algorithms. So while the Hatzivatsaloglu and McEwen algorithm automatically finds the sentiment or the polarity of individual words, it doesn't do well with phrases, and we'd like often to get phrases as well as words. So the Turney algorithm is another way to bootstrap in a semi-supervised way a lexicon. What this does is extract a bunch of phrases from reviews, learn the polarity of the reviews, and then take all the phrases that occur in a review, take their average polarity, and use that to rate the review. So let's look at these stages in the Turney algorithm. First, we're going to extract every two-word phrase that has a particular set of part of speech tag. And we haven't talked about parts of speech yet, but so this is adjective, the tag for adjectives. So if the first word is an adjective and the second word, this means noun, and this means plural noun. So if the first word is an adjective, so an adjective followed by a noun or a plural noun, we'll extract that phrase, whatever the third word is. Or if the first word is an adverb, RB means adverb, and the second word is an adjective, and the last word is not a noun, we'll extract that phrase. So adverb, adjective, 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 noun, adjective, adverb, verb. So these are particular phrases. So we're going to run our part of speech tagger. We'll talk about that in a few lectures, and assign for each word a part of speech, adjective, noun, and so on. And then we'll extract two-word phrases that meet these criterion. The first word is this tag, second word is this tag, the third word has some constraint so that we don't extract it. And now we look at all those phrases. And our goal is for each of those phrases we've extracted to measure its polarity. So how positive or negative is a particular phrase. And the intuition of the Turney algorithm is, just like the Hatzavasa-Loglu and McEwen algorithm, to think about co-occurrence. So we ask, well, a phrase is positive if it co-occurs a lot nearby, let's say on the web, or some large corpus with the word excellent. A negative phrase is likely to co-occur more often with a word like poor. So how are we going to measure this co-occurrence? The standard way to measure this kind of co-occurrence is by point-wise mutual information. Point-wise mutual information. And that's a variant of a standard information theoretic measure called mutual information. The mutual information between two random variables is the sum over all the values the two variables can take of the joint probability of the two times the log of the joint over the individual probabilities. So point-wise mutual information takes this intuition from mutual information and just asks a very simple, computes a very simple ratio. The probability of two events, x and y, divided by the product of the individual probabilities. So what point-wise mutual information is asking, it's a ratio, is how much more do two events, x and y, co-occur than if they were independent. If they were independent, they would have these independent multiplied probabilities, and how much does the joint occur more often than we'd expect from independence? That's the intuition of point-wise mutual information. So looking at point-wise mutual information, I've just repeated the equation here. We can look at it between two words. We say, how much more do these two words, word one and word two, co-occur than if they were independent by taking the ratio, the probability of the two words occurring together, divided by the probability of each word separately and multiplied, and we take the log of that. How do we estimate this? Well, the way Turney did it originally is by using the AltaVista search engine. And we're going to estimate the probability of a word just by how many hits we see for that word. And we're going to estimate the probability of two words by how often word one occurs near word two. So AltaVista has the near operator that lets us check if a word is near another word. And in each case, we're going to want to normalize to get a real probability from these counts. And by our definition from the previous slide, point-wise mutual information, it's the probability of the joint, so that's hits of word one near word two over n squared, divided by hits of word one over n over hits of word n2 over n, and these n's are going to cancel, and we're going to end up simply with this equation. So how many times do the words occur near each other? How many times do they occur individually, multiplied together? So once we have a measure of co-occurrence, of how much a phrase co-occurs with the word excellent or the word good, we can now determine its polarity. So the equation for polarity in the Turney algorithm is just how much is the mutual information, the point-wise mutual information of any phrase with the word excellent, and we subtract its mutual information with the phrase poor. So how much more does the phrase appear with excellent than poor, or vice versa? And just doing a little algebra. So that's the number of Here's the definition of pointwise mutual information of a phrase with excellent, how often it occurs near the word excellent divided by the individual number of hits of the phrase itself and excellent, and then subtract the same thing for poor. And of course, by the definition of logs, we can bring things inside the log and turn the minus into a divide. And then we can do some messing with terms. So we have hits of phrase here, and we have hits of phrase there. And so in the end, we can get our formula for deciding the polarity of a phrase. It's just how many times does the phrase occur near excellent times how many times it occurs with the word poor occurs over how many times the phrase occurs near poor over how many times excellent occurs. So these are constants that we can get once, and then for each phrase we can compute these two quantities. And using the Turney algorithm, here's a positive review, obviously of a bank. And so here's a phrase like online service, adjective, noun, phrase. And here's the polarity assigned by it, 2.8. Here's another one, direct deposit, 1.3. And here's some negative phrases with negative polarity. So the phrases occur more often near the word poor than near the word excellent. So inconveniently located has a negative polarity. So on average, though, I've just shown you a subset, more of the positive phrases occur in this review than the negative phrases, and the average polarity is positive. So this is a thumbs up review. A thumbs down review, you can see that phrases like virtual monopoly, negative polarity, lesser evil, negative polarity, other problems, negative polarity, all occur more frequently and on average have a more negative polarity than the positive polarity words that occur in this review. And we end up with a review that has an average negative polarity. So the Turney algorithm was evaluated on various kinds of review sites and does a better job than just the majority class baseline at predicting the polarity of a review. So what's important about the Turney algorithm is that it lets us look at phrases, learn phrases rather than just words. And what's true about in general about these unsupervised algorithms is we can learn domain-specific information that might not be in some online dictionary. So if I go back to the previous slide, if we're doing banking, a word like direct deposit or virtual monopoly might not be in an online polarity dictionary or online web. So we need to use some of these semi-supervised algorithms for learning the polarity of these kind of words. Finally, I'll mention briefly a third algorithm for learning polarity, and this uses WordNet. Again, that's the online thesaurus that we'll talk about in detail later. And the intuition of using these online thesauruses is as similar to what we've seen in the first two semi-supervised algorithms. We'll start with a positive seed set and a negative seed set. So we might have words like good in the positive seed set and terrible in the negative seed set. And now we use the thesaurus just very simply to find synonyms and antonyms. So we add synonyms of positive words like well and antonyms of negative words to the positive set. And to the negative set, which we started out with words like terrible, now we add synonyms of all those words. So maybe awful is a synonym of terrible. And antonyms of our positive words to the negative set, and we just repeat. And the sets grow as we keep adding synonyms and antonyms to it. And then each of the algorithms that make use of WordNet for learning polarity will have various ways of filtering out bad examples or problems with word senses and things like that. So in summary, learning lexicons can help us deal with domain-specific issues. In banking, we might have a word like direct deposit. That's just not going to be in a standard online polarity lexicon. And we can be more robust in general as new names or people start using new names or a new company name might not be in some training data, but we might be able to learn it from the web or from the data we're looking at. And again, the intuition of all these algorithms is really the same. We start with some seed set. We find other words that have similar polarity to that seed set in some semi-automatic way. And the ways we've seen are using whether the words are conjoined with and or but, using words that just occur nearby to words like poor or excellent. So that's our seed set there, or using WordNet synonyms or antonyms.